Alright, hello, this is the Helicopter Flying Handbook. I'm on Chapter 12, going to be on page 3 of 6, Helicopter Control. Control of the helicopter is the result of accurately interpreting the flight instruments and translating these readings into correct control responses. Helicopter control involves adjustment to pitch, bank, power, trim in order to achieve a desired flight path. Pitch attitude control is control of the movement of the helicopter about its lateral axis. After interpreting the helicopter's pitch attitude by reference to the pitch instruments, the attitude indicator, altimeter, and airspeed indicator, and the VSI, cyclic control adjustments are made to affect the desired pitch angle. A pilot transitioning from airplanes to helicopters must understand that the attitude indicator is mounted in the airframe beneath the main rotor system and does not directly indicate that the main rotor system is doing to the flight path. Therefore, the helicopter can take off and climb with the nose below the horizon. The helicopter can slow down and land with the nose above the horizon. In contrast, the airplane must be pointed generally in the direction of travel, up or down. Since the attitude indication is firmly attached to the airframe, that is firmly attached to the wings. The helicopter tends to fly through the air at some stabilized attitude, and effect developed by horizontal stabilizers and designed to minimize drag in forward flight. As the helicopter begins to take off, acceleration begins. As airflow increases over the horizontal stabilizer, it produces a downward force to bring the nose into the stabilized attitude to streamline the airframe into the relative wind. Therefore, the helicopter's attitude indicator is about level when at a stable airspeed and at altitude. A nose-low attitude indicates acceleration, not necessarily a descent, and a nose-high attitude indicates deceleration, not necessarily a climb. These effects make the helicopter pilot interpretation of the instruments even more important because the pilot must integrate the results of the entire instrument scan to achieve complete situational awareness of the helicopter to flight path. Bank attitude control is controlling the angle made by the lateral tilt of the rotor in the natural horizon or the movement of the helicopter about its longitudinal axis side to side. After interpreting the helicopter's bank instruments, attitude indicator, heading indicator, and turn indicator, cyclic control adjustments are made to obtain desired bank attitude. Power control is the application of collective pitch with corresponding throttle control where applicable. In straight and level flight, changes in collective pitch are made to correct for altitude deviations if the error is more than 100 feet or the airspeed is off by more than 10 knots. If the error is less than that amount, use the slight cyclic climb or descent. When flying a helicopter, by reference to the instruments, pilots should know the approximate power settings required for a particular helicopter and various load configurations and flight conditions. Force or cyclic trim in helicopters refers to the use of cyclic centering button if the helicopter is so equipped to relieve cyclic pressures. Trim also refers to the use of pedal adjustments to center the ball of the turn indicator. Pedal trim is required during all power changes. The proper adjustment of collective pitch and cyclic friction helps pilots relax during instrument flight. Friction may be adjusted to minimize over-controlling and prevent creeping, but not applied to such a degree that control movement is limited. In addition, many helicopters equipped for instrument flight contain stability augmentation systems for an autopilot to help relieve pilot workload. See FAA H.12-ATTITUDE Instrument Flying Handbook for a detailed explanation and illustrations concerning helicopter attitude instrument flying. We're ending right there. That's page 4 of 6. Page 4 of 6, Helicopter Control in Chapter 12.